And we'll move next to the speaker, Dr. Karen Lozano. Karen, I think I saw you here. There you are.
Yes, I'm here. Hi, how are you?
Great. Wonderful to see you. She's a former colleague. We used to work together at the same institution. She is the Julia Burchell Endowed Professor of Mechanical Engineering at the University of Texas, Rio Grande Valley. And Karen, I'm just going to turn it over to you.
Thank you. Thank you. Let me share my screen. Okay, let me see.
I can see your slides, Karen.
You can see my slides? Okay, let me just hide this bar. Can you see them well now?
Yes, I can.
Perfect. Thank you. Thank you so much. Good morning. And thank you so much for the invitation. My most sincere gratitude to the National Academy of Engineering Committee on Extraordinary Engineering Impacts on Society. Thank you for giving me this honor to share the story of our center. I think a center that is not in the big leagues as the ERCs, but we're getting there. We're going to go there. But certainly the impact that our center has had on society is certainly in the big leagues. So let me quickly start by, this center is it's a center that has taken about 23 years to be written, and the story is going strong. And I will start by sharing what happened before those 23 years. So that's basically a little bit of my engineering pathway. So I was born in Monterrey, Mexico, to very hardworking parents. I had no engineering role models. I've been listening to all of the previous speakers, and I've been very interested to learn their role models. In my case, I had no engineering role models. My family always struggled to make ends meet. And I started working at a very young age, about 11 years old. I started selling dresses door to door that my mom would make. And then I held some jobs as a waitress. This is when I was working at Cirlon Estocade, and some other jobs, here and there. When it was time to consider what to study, my major, I thought mechanical engineering was a good one. It was engineering could pay well, and I could help my family, but engineering was for men. So my mom naively, she studied up to 6th grade, and naively she mentioned like if it was illegal for women to pursue engineering, and I said, well, it's not illegal, but women are just not there. She said, well, how about if you pursue the path less travel? And the adventure started. So upon graduation, I faced quite a challenge. Back then, jobs were listed on the newspaper. And as you can see, I was having a big challenge. The requirements, you had to be a male, certain age, certain civil status. And that was basically all of the jobs that were on the newspaper. So I was very lucky that 2 professors from Rice University traveled to Monterrey to start a collaboration with my university. And Dr. Barrera gave me an opportunity, Dr. Rick Barrera gave me an opportunity to join his research team at Rice University. And I really, I thought I was going deeper into the engineering problem. I had no idea what was going to happen. And if graduating with a PhD in engineering, after all the, rejection that I faced, for about 6 months, I didn't know if I was going to, that it was going to change my situation with the degree, but I had no options. So I went in, and upon graduation, I had no idea what to do. Then, surprisingly, I received an offer from University of Texas Pan American. I didn't apply to, but that's a story for another occasion. But I received an offer, and one of my colleagues, some of my professors didn't want me to attend or didn't want me to join because it was a teaching institution, and they said, you're not going to do any research. And one of my classmates says, well, just go to a place where you can make a difference. And that was like kind of resonated, but I didn't really know if that was the place that I could make a difference. So, was this the right place? I don't know. Edinburgh is where the University of Texas Pan American back then, right now is the University of Texas Rio Grande Valley. In 2015, it resulted as a merger of two institutions. But back then in 2000 was the University of Texas Pan American. And as I said, it was a teaching institution located at the very south tip of Texas. Here are some of the recent statistics of the University of the UTRGV and some of the statistics from the area. Back then, the 6-year graduation rate was 30%, and the first year retention rate was 61%. So it's an area where over 50% of the K-12 students are considered at risk. An area that is ranked high in job opportunities, but it's quite at the bottom of, the Forbes does a ranking, and we rank 148th in education out of 150 metropolitan areas. So could I be an agent of change, in this university? I guess naively, I joined the university and was the first ever female professor in the Department of Mechanical Engineering. And I, even though not required back then, and thinking back, probably fully naive, but full of dreams, I started writing proposals, never saw an example of a proposal, had very little knowledge of the processes. Our office of sponsored research was staffed with 2 people, the grants and contracts with 1 person. My lab had long, great empty benches, and that was all. So I needed equipment if I wanted to do research. And I was very blessed to have received an MRI, a major research instrumentation, and I bought a rheometer and a polylab system. My expertise was nano-reinforced polymer composites, and that was just the perfect catapult to start everything. Next, I dive into the career proposal, and I am eternally grateful for the NSF, FAIR NSF panel that believed in me. I had everything against. The teaching load was 4-4, no PhD program, students that have started with very low entry scores, and totally lack a research conducive environment. So had everything against except the novel ideas and the will to make it happen. So after that, I received other funding from NSF, such as some NER, NIRT, and some unsolicited proposals. And basically, the nano team was formed, and we had students asking for opportunities to participate in research projects all the time. My colleagues will joke with me and saying, you need to put a neon sign outside your door that says no vacancies, and then turn it on and off whenever you have vacancies on the team. We needed to grow opportunities and collaborations, and the PRIM program sounded like the next perfect step. We were funded in 2009, and a partnership with the University of Minnesota started. It was a fruitful, it has been a very fruitful opportunity. Dr. Tim Lodge, the MERSEC director, has been a blessing for all of us. We have learned so much from him and other MERSEC faculty, and opportunities for our RGV students grew. We are now in our 3rd cycle. We have graduated several hundred of students. We have had 100% retention in graduation, a female representation in engineering way above national statistics, and over 90% Hispanic students at the undergraduate level. It is worth noting that our, we have also very high, output of technical results. So we're not a center that says, okay, well, you're only showing opportunities to students. You're kind of doing an outreach, you're playing in the very minor league, but you're really not producing anything. We have produced over 200 peer-reviewed journal publications, and 85% of these co-author with undergraduate students. 20 patents or patent applications. We've given close to 400 presentations, and our contribution to graduate school has been superb. The average ACT of the students that are part of our team is 19. These students will have had a very slim chance of being admitted to any tier 1 institution. And now many of our students hold PhD degrees from those institutions. So our contributions to underrepresented minority to graduate schools nationwide has been superb. And let me just quickly glance at some statistics. Data from Science and Engineering Indicators on female and underrepresented minority in engineering shows that the gender gap in engineering has basically remained flat for the last 30 years. Women make about 20% in engineering, and in mechanical engineering, less than 15%. For underrepresented minorities, at the undergraduate level for Hispanics, we see that Hispanics males represented about 6% of the bachelor's degrees in engineering back in 2008 and 8% in 2018. Latinas, it was about 2% in 2008 and 3% in 2018. Though for the graduate level, the numbers are really sad. Latinas, for example, in 2018 represented 1% of all awarded MS and PhD degrees in all engineering fields. And in mechanical engineering, no data was shown for Hispanic male and female, meaning is way less than 1%. So what is it that we as the center are doing to have the, I guess, well, yeah, we have to do more. There's a lot more that we can do. And our area has vast potential to be that pathway, because everybody in every program that NSF announces has this broadening participation and, minorities. And we are an area that has potential to make a lot of that happen. So our nano team, what is it we have done to have this 100% retention and graduation, even though the statistics that I show you about our local area. So our center basically, there are many centers, as I mentioned, that are focused on trainings, offering workshops, evaluations, data analysis, research on how Hispanics learn, and so on, right? But the recipe to achieve this 100% retention and graduation is based on students playing active roles in the research projects. It is certainly important that they participate in workshops and of what's available and other opportunities, though hands-on will always top the chart on motivation and engagement of students. And another thing is that it's established that deep connection with the faculty. It's not that we bring the students for a one-time thing and then we just put on numbers of how many underrepresented we had impacted. These are students that we have stayed connected with them for years. I'll tell you a case of this particular student in just a little bit. So our center offers a sense of belonging. Basically, belonging to a productive research team improves students' motivation. They respond very well when realizing that somebody expects results from them. Clarification of educational goals. When they see the relevance of their studies to the real world, they start considering graduate school for the first time. And when they consider graduate school, that means they're going to graduate with an undergraduate. So that's the winning thing for us. The work experience, hands-on research experience, they help the students to become aware of latest technology breakthroughs, allows them to learn complex concepts, develop writing and communication skills. They face failure and solve problems. Just way too many hard and soft skills. So our prem, our center teaches the importance of work ethics, hard work, discipline, responsibility, persistence, determination, everything that a person needs to be very successful in life. So let's see the next slide. Okay, so our center has created a culture of achievement among the students. And how is that you can achieve success with the students and I guess the boundary conditions that we have. So we basically, the key answer is we have to develop projects very strategically. There's sometimes things that we want to do that are a little deep and more complex, and maybe we will have to bypass that or start a collaboration with somebody else to do that. But we have to make sure that the projects that we develop are not easy. We're not saying they're easy, but they're realistic within their boundary conditions. And due to time constraints, I'm just going to focus on one of the projects that that we've been working on. So nanofibers, this project, I should say, again, was driven by the need to find safe, engaging projects for our students. So our expertise was on nanofibers reinforced polymer composites. We started trying to make our very own nanofibers, and nanofibers have shown tremendous opportunities in many, many different markets, many different areas, and just way too many research opportunities. And the process that we had available to make nanofibers was electrospinning. The output is very small, like 0.3 grams per hour. Knowing that we had to impact undergraduate students and engage them, this was very little to actually make a difference. And it was a project that we really were not considering. So one day, eating cotton candy with my sons, I realized that I was eating a lot of fibers through a process that every student in my lab had eaten cotton candy, and they understood the process very well, centrifugal spinning. So how about if we can make nanofibers at a larger scale using centrifugal spinning? And long story short, we created a company. We tackled the challenge of making nanofibers with centrifugal spinning. And we founded a startup with a visionary entrepreneur and a great group of engineers, many that have recently, or that they had recently graduated from our own center, and they were hired to make possible the design of industrial systems. And these industrial systems now producing hundreds of meters of nanofibers per minute. The force spinning, as our technology was coined, received worldwide attention. Hundreds of CTOs traveled to our border town, so many that I received a visit from the FBI asking what was going on at Fiber Rio, since our border airport was, lately quite busy and with very unusual visitors, CEOs and CTOs and technology scouts, and they just wanted to know what was going on there. Our technology received notable awards such as the R&D 100, the 100 Global Clean Tech, and some more. And we have many other projects that we're working within the center, but we just don't have the time right now to present all of them. Another very important activity that we consider essential for our center is our outreach for our K-12 population. As much as we want to be the pathway for underrepresented minorities, for all of you, or for all of the centers out there, the ones playing in the big leagues, we also have to have the students that will come and join our center. So we have to do lots of outreach. And we participate in summer camps. We are right now the host for the Regional Science Fair, the one that leads to the Regeneron International Science Fair, previously known as the Intel Science Fair. And we're basically involved in a lot of them. But one activity that I would like to call the attention right now is our most recent Energy and You movie. This was presented via Zoom to over 15,000 students. I'll show you a quick video about it. This is based on a theater production that was originally developed at the University of Minnesota, and we obtained funding from NSF to migrate it to South Texas, and then COVID hit. So we had to improvise. We adapted the script and the demos to make a movie, and it was a full success. Energy and You teaches about the first law of thermodynamics with live demos, dances, and parkour. We'll showcase this 35-second video of one of our most recent presentation, and the plan, this was through Zoom, and the plan is to go live in January 2023. Let me show you this quick video. Can you create energy? No! Can you destroy energy? No! What can you do with energy?
you learned and you had fun. That's amazing. And you dance. I saw many of you dancing.
Okay, so hope you liked the video. We enjoyed that activity a lot. It's a lot of work, but we enjoy it tremendously. And so we can we measure with numbers all the impact that our center has had? Well, sure, for the most part. So our NSF investment in our center over the last 23 years has been approximately $20 million. This is combining all the different grants that we had. We have not had the opportunity to have like a real large grant where we could focus a lot of the efforts. We have to be writing grants all the time, and that for us is very time consuming because we are the ones that write it 100%. We don't have grant writers, so it's time consuming, and we'd like to have maybe eventually work on a bigger grant so then we can focus a lot more of our attention on the students. But we're very grateful right now to the program that has been our catapult to move into that direction. We have had 100% retention of graduation of lots of students. There's the university has 40 back then. This is 30 and now 55% 6-year graduation rate. Several hundreds of students have pursued MS degrees and 45 PhD degrees. Nationwide statistics are very low, as I said, for women, one and one for engineering and mechanical engineering, basically none. These are just a few of the women Latinas that have come out from our group, and right now they have or PhD degrees or are moving or almost getting their PhD degrees. Veronica, I wanted to mention a little bit about Veronica. Veronica graduated in 2002, and then 16 years later came back to me and say, I want to do my PhD. Can you please help me? So I was a co-advisor. I was a part of her committee. Was the committee also for Maricela Liscano. So we stay in touch with them. Every single student, every one of the 500 students that have directly benefit from our center, we stay in touch with them. So collectively, these 500 students that have benefited from the center, they're earning about $40 million a year, considering conservatively a salary of $80,000, which they earn more than that. But that's $40 million a year. So if we count the tax, just calculating 18%, 20%, that's about $8 million a year. These students came from families that their family annual income was $30,000. And right now they're bringing back to the community about $8 million in tax revenue, $40 million a year. So the price and societal impact of our center is just priceless. You cannot measure it with a number. So we are now ready to explore bigger and better opportunities to further catalyze engineering impacts on society. We have proven that we can do it, and we're ready to look into something else. I would like to deeply acknowledge, National Science Foundation. Their trust has made a tremendous difference in our area. Certainly the committee of National Academy of Engineering committee that invited us to present, and all the wonderful students, colleagues, staff, and administrators at UTPA and now UTRGV that have participated in our once naive vision. So basically, we are in all social media showcasing what our centers do. We have to, I guess, that's the way to get in touch with the students. And I guess go to a place where you can make a difference. Thank you very much.
Fantastic, Karen. You continue to just amaze me, really. I first met Karen when she was an assistant professor years ago. We are going to, Karen, I hope you can stay for the roundtable. We're going to ask you questions then so that we can go to break right now and start on time at 12:20. So thank you so much for that inspiring presentation. So let's go to break, and if you can please return at 12:20. Thank you.